Welcome. In this video, we are going to take a look at problem 40 from chapter 4 of College Physics 2E from OpenStax. All right, and so we have a flea that's jumping up off the ground. All right, the flea exerts a force straight down on the ground, so the ground will exert the same amount of force straight up on the flea. All right, and so let's start our list of knowns. And so we know that the force down by the flea is going to be the normal force up by the ground. And that is 1.20 times 10 to the minus 5 newtons. All right. We have a breeze on the flea, so let's just call that a breeze force. It is 0.500 times 10 to the minus 6 newtons. We need to find the direction and magnitude of acceleration, and we know the mass of the flea is 6.00 times 10 to the minus 7 kilograms. All right, let's make our free body diagram for the flea. So these are all the forces on the flea. Okay, so we'll put our X and our Y like that. All right, so we know we have that normal force by the ground. We know we have a breeze force by the wind. And then the flea will have a weight, and we are told not to neglect that. All right, so now we can apply Newton's second law. So we will sum the forces in the x direction. They will be equal to the mass of the flea times the acceleration in the x direction. All right, the only force in the x direction is the breeze force. So we have B is equal to ma sub x. All right, so we divide both sides by the mass. We find the x component of acceleration is the breeze force divided by the mass of the flea. All right, breeze force is 0.500 times 10 to the 6 newtons. We're going to divide that by 6.00 times 10 to the minus 7 kilograms. Dividing gives us a value of 0.833. We can keep the units as newtons per kilogram or the equivalent meters per second squared. All right, so there's one component of acceleration. Let's apply Newton's law in the y direction. So the sum of the forces in the y direction is equal to the mass of the flea times the y component of acceleration. All right, in the y direction, we have the normal force up and a weight down. So we'll have the normal force minus the weight is equal to ma sub y. We can replace the weight with mg. Weight is equal to mg. Now to find ay, we just need to divide each term by n. Each term by m. We're going to have n divided by m minus mg divided by m. So that's just going to be g. All right, so ay is our normal force, 1.20, 10 to the minus 5 newtons, divided by the mass, 6.00, 10 to the minus 7 kilograms, and then minus 9.8 meters per second squared. Notice that g itself doesn't carry a sign. It's always taken to be a positive quantity. So we don't introduce a second negative sign there. All right, a sub y ends up being 10.2, and that's going to be meters per second squared. So now we have the two components of the acceleration, so we can find the magnitude. And we'll use the Pythagorean theorem. So the magnitude of the acceleration is the x component squared plus the y component squared, and then we'll take the square root. All right, so substituting the values, we have 0.833 meters per second squared. We square that quantity. plus 10.2 meters per second squared, and we square that quantity. I found this was 10.23 meters per second squared, and to 3 sig figs, this is 10.2 meters per second squared. It is very similar to the y component, but it is slightly bigger. It's just taking the sig figs knocks one digit off. All right, the direction is the tan inverse of the y component, so ay divided by the x component, ax. So we've got the tan inverse of 10.2 divided by 0.833. Note, I did not put the units there because they're just going to cancel. I calculated this, and let's see, I got 85.3 degrees. And so this is from the positive x-axis, which is the ground. So this is measured from the ground. So we'll say from plus x. Pretty standard way of measuring a direction. All right, that's going to do it for that problem. I hope that helped, and I'll see you in the next one.